Okay, so now we will discuss the phase change process of pure substance. So previously, if you went through the videos of pure substance, we discussed we have three different phases, and now let's discuss how this phase change process actually happen. So here actually we got a piston cylinder device. So let's say this is the piston, this is the piston, this is the cylinder. It is filled with water at 20 degrees centigrade temperature and 1 atmospheric pressure, so 1 atm pressure. So this is actually we said at 20 degrees centigrade it is liquid and it is compressed liquid, or we can say actually this is subcooled liquid under this condition, because this condition we say this is state 1. So this substance, it is not about to vaporize. We know in reality water actually stayed vaporize at 100 degrees centigrade temperature and 1 atmosphere pressure. So this temperature is 20 degrees centigrade. It is not about to vaporize, so we can say this is compressed liquid. So what will happen if we increase? So let's say this is actually the the cylinder, and if we have the piston here like this, so this is water. If we increase the temperature like 40 degrees centigrade, so if we put some some energy at the bottom of this cylinder, and then if we increase the temperature up to 40 degrees centigrade, what will happen? That means the temperature will increase and the liquid water, so this liquid water here, it will expand a little bit, not that much in this case. So this drawing is not good. So what will happen? So let's say the temperature initially for 20 degree was this, so maybe we can experience a little expansion. Okay, water will expand, and due to this expansion, to accommodate this expansion, this cylinder will rise little bit at 40 degrees centigrade. Okay, so it will move slightly. The pressure, it will be constant always. We say pressure is 1 atmosphere, so 1 atm. Okay, so the pressure is constant. Now let's say it is at 40 degrees centigrade. We said that the temperature will expand and the piston will move slightly, but if we increase the temperature a bit more until 100 degrees centigrade, let's say this is a state 2. So if we increase this temperature 100 degrees centigrade, then what will happen? At 100 degrees centigrade temperature, okay, if we put more heat, and the liquid, it will expand more, and the volume, the specific volume will increase. Okay, and at this point water is still liquid, but it is ready to vaporize. Okay, so it is about to vaporize, and in this case, when a liquid is about to vaporize, we can say this is saturated liquid. So we will use this term again and again throughout the semester, like the saturated liquid, saturated vapor. So it is about to vaporize, and what will happen at 100 degrees centigrade temperature? That's the situation where phase change process will start. That means water, so this is the liquid, okay, liquid will start vaporizing. So this is the liquid is one phase and the vapor is another phase. That means the phase change will start here. Now if we move to the next slide, see, this is state 3. So that means at 100 degrees centigrade and 1 atmospheric pressure, the boiling starts. So when boiling starts, temperature won't increase anymore. You say what I said? I said when it is 100 degrees centigrade temperature, so we have this system, this is the piston, here we have water, and temperature is 100 degrees centigrade. When it is 100 degrees centigrade, it will start boiling, and this temperature won't change. What will happen? You see, at 100 degrees centigrade temperature, we still have this liquid, and some liquid will transform to the vapor at 100 degrees centigrade temperature, and the temperature will be 100 degrees centigrade until all saturated liquid will transfer to the vapor. Because if you check this, you just use a thermometer, maybe you are boiling some water, use a thermometer, put it there, you will see the temperature is 100 degrees centigrade. So the temperature will remain constant during this phase change process, and if the pressure is constant. If the pressure is if not constant, then it won't. So I will show you a video later on, and then you can understand it. So what I said, at 100 degrees centigrade temperature, it will start boiling, and the saturated liquid will become saturated vapor, and this process will continue until every drops of liquid water becomes saturated vapor. So this phase 3, it is actually the middle. It is the middle of the the phase change process. You will see at some stage there will be 50% liquid, 50% vapor. But state 4, it will be some situation where there will be no more saturated liquid. All saturated liquid will transform to saturated vapor. Okay, this is saturated vapor. So let's say what is when this saturated vapor and saturated liquid are equal, we can say this is the equilibrium state. But I said this phase change process will continue, and after a certain period of time there will be no saturated liquid, not a single drop, and it will become saturated vapor, like this is state 4. And at this case, at this stage 4 condition, we said this is saturated vapor stage, and this saturated vapor, we can say saturated vapor is something, a vapor that is about to condense. So if we if there is any heat loss from the vapor, so we said this is vapor. So if there is any heat loss from the vapor, so that will cause some vapor to condense when the phase change will happen from vapor to liquid, and this is actually called the saturated vapor. So this is a state 4. And simply keep in mind, state 4 here is there will be not a single drop of saturated liquid, all will be saturated vapor. Now the phase from 1 to 4, if you can remember, 1 it was only liquid, 2 it was about to vaporize, state 3 it is equilibrium, and state 4 only vapor. So this condition, state 1 to 4, we can say this is actually the saturated liquid and vapor mixture, this total state. And now what is superheated vapor? You see the superheated vapor. If we so when it is a state 4, it is only single phase, because we have only vapor, so it is a single phase. So phase change already completed, it becomes a single phase, which is only the vapor. And now if we transferred more heat, then what will happen? Let's say 300 degrees centigrade, but the pressure is constant always. If we put more heat, the only change will be the specific volume will increase and the temperature will increase. Okay, so you see the volume, look at the level here and here, it's increased because we put more temperature, so the specific volume increase. And at state 5, the temperature of the vapor, let's say 300, and if we transfer some heat from the vapor, it may somehow drop a little heat from this vapor, let's say 250, but it will not condense, because to condense we need to get the temperature like 100 degrees centigrade. So the temperature is above 100 degrees centigrade, so no the vapor will condense here. So that means it is superheated vapor, and superheated vapor means it is not about to condense. And if there is no chance for condensation, then we can say the vapor is superheated vapor. So if we see the process, you see initially the temperature was 20 degrees centigrade. Now that time it was compressed liquid. At stage 2, you see the phase change process starts, and up to stage 4 the temperature was constant that I mentioned earlier. It will be constant 100 degree, and after when it is the phase change completed, then temperature will increase again. So that will be the curve when the phase change process will happen, and this is actually the TV diagram, the temperature and the volume diagram with constant pressure. Now look at this animation here. You see initially the temperature was here, and then it increased. Then this is stage 2, 3. So this is, you see, this is 1, 2, 3, 4. The temperature constant, and then you see increased. It is for constant pressure. But if we increase the pressure like to atmospheric pressure, you see the boiling temperature increase. It's more than 100. We will discuss later on this. Okay, so I think that's all, and we'll discuss more details during the lecture.